Hello and welcome everyone. Thank you for joining us today for our webinar titled Enterprise Architect Guide to H2O Open Source for Model Building and Deployment. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Greg Keys is a PhD and Senior Solutions Architect at H2O.ai. Now before I hand it over to Greg, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the Questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Greg.
Hello, everyone. Welcome to the webinar. Many of you may have experience with H2O Open Source. If you don't, it's a machine learning library and product and platform to build predictive models. Many of you may have experience with it, but the focus today is on putting that software and usage into an enterprise environment where, enterprises are very guarded about how software is used and deployed and stuff like that. So this is sort of a view of how to use this from an enterprise standpoint. For example, you're a large bank, a large insurance company, or you just very carefully protect your systems. So what I'd like to do first is just briefly review what we're going to do today. So we'll just take a very quick overview of H2O.ai, who we are, and then we'll have a very quick overview of machine learning, what it is. If you're not that familiar with it, this will just be a super brief 101. And then we'll get into what H2O Open Source is. And then we'll look at why H2O Open Source has value for multiple stakeholders. Usually when you say machine learning, you're talking about data scientists, but when you think about it, you have to go from data science to putting models into production where they achieve business value, and there are a lot of stakeholders around that full chain. Then what we're going to do is we're going to dive in deep. Put on your seat belts because things will get a bit technical at this point. We're going to look at architecture views of H2O Open Source from a model building standpoint. And then we're going to concentrate on the security and governance capabilities around it. Then I'll do a quick demo just to make things real. And then when we talk about machine learning, as I've indicated before, there's the stage of model building. And then there's the stage of taking that model and putting it into production and having live data against it and making predictions and responding to those predictions and achieving your business value, whether that's building an application around it or just some sort of process to respond to the predictions. Deploying that model, even though, as I said, building the model gets a lot of attention, deploying that model is really the last step that needs to succeed for the machine learning endeavor to succeed. And so we'll take a similar look at the technical aspects of H2O Open Source from a model deployment standpoint. And then I'll just summarize things quickly, and then we'll go into the Q&A with about 10 minutes left. So quick overview of our company. We're a private company. We've been through 4 rounds of funding. Our CEO is a man named Sri Ambati. He's a very visionary and entrepreneurial computer scientist. He's led multiple companies, and he's at the helm of H2O.ai since 2012 when we formed. I'll sort of give you a big overview of everything we do at the company, even though today we're going to be focusing on H2O Open Source. And we are global. When you look at the employees inside of our company, we are a machine learning focused company. So pretty much everyone is an expert in machine learning. And we're used by lots of companies, lots of universities and so forth. And again, that usage can be sort of casual, using H2O on your laptop, or it can be highly formalized, for example, running fraud detection models based on terabytes of data of real-time point of sales credit card systems or whatever. So what I'd like to do now is just sort of show you who our customers are As you can see, I mean, almost half of of the Fortune 500 use us. So we're talking about some really recognizable names. And 8 of top 10 banks and the top 10 insurance companies use us. H2O Open Source is used in most of those top banks and insurance companies, and they are really running predictive models against all kinds of use cases to basically transform their businesses into an AI business, because I think we know tracking technology, the internet became big, et cetera, et cetera. Right now, machine learning, AI is transforming the industries. So very quick overview of what we have to offer. We today are going to concentrate on open source. If I had to put one phrase on what is H2O open source, I would say building predictive models against massive data sets to create highly accurate models, highly predictive models. We have another machine learning product called driverless AI. It does the same thing. It builds predictive models and allows you to put those into production very easily. But this is a little bit more focused on automation. It's a little bit more focused on getting to those predictive models in a faster way. So if, you know, a large bank is building fraud models, they may take 2 or 3 months to do that, running against terabytes and terabytes of data. But driverless is more about taking what would take months to do in days. So driverless is more about getting a model factory going, just cranking out predictive models. But it does at this point have limitation of not going against massive data sets. So driverless is more about automation, about time to value. Open source is more about diving in against large amounts of data and then just working way towards that, that final model. And then we have a new product called H2O. It's really a platform to build your own AI apps, and it's attached to an app marketplace. Obviously, that's a whole new discussion, a whole new webinar. And then we have an H2O Model Ops platform, which is a platform to host the predictive models created by open source and driverless. I'm going to show you all the technology around how to put your models into production, and putting them on your own systems is certainly, you know, a common thing to do. But an alternative is to put it into H2O Model Ops, which has some benefits around it, like monitoring drift. Machine learning is really sensitive to the data that was trained on, and if that data changes over time, you probably have to retrain it. So Model Ops has capabilities to detect drift in production and things like that. But as I said, we're going to focus on open source specifically. So here on out, this is a discussion about open source, and it's a discussion about using open source in an enterprise environment with all the processes and governance and stakeholders and everything that goes around that. So let's do a very quick machine learning overview. I apologize if you're very familiar with this. If you're a data scientist, it won't be that extensive. But if you're more of an architect with some knowledge of machine learning, this will be a quick recap. And then let's take a very high-level look at H2O Open Source, what it is, and then look at what H2O Open Source means from multiple stakeholder perspectives. Because, as I said, if I'm just a data scientist working alone, you know, I can kind of do things on my laptop. If I'm a data scientist working on a Hadoop platform, there are many people involved with that. And we need to sort of look at all of those perspectives, because that's the enterprise world that you live in and that you sort of abide by. So what is machine learning? Really fast, I'll just use these 2 quotes to summarize some things. The first quote, I think, just sort of gets at the hype around machine learning. I think most won't say it's hype in the pure sense of the word. I would say most would say it's hot, because being able to build predictions and responding to them is obviously a very powerful thing to do, as opposed to looking at data from the past and responding to that. So, you know, what is machine learning? It's a way for algorithms to learn the best mathematical rules to predict outcomes based on data that's fed to them. So typically what you do, and here I'm talking about supervised learning, is you take data with an outcome. So let's say you have, the past 2 years worth of insurance claim submissions, and then all of those submissions have an outcome of what you determined in the past. Does it have fraud? Does it not have fraud? You feed that data with the outcome into the machine learning algorithms, and they are optimized to just iterate and iterate and iterate and iterate, and then improve, 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 and predict and predict and predict, and finally come up with a model that predicts with a certain amount of accuracy or other measurements or metrics, how well that model's doing. And when you're happy with training the data, you take that model and then you put it into a production environment, and now you feed it live data, and of course you don't know the outcome of current fraud submissions, but you get predictions based on that model, based on the training. What's the likelihood of this being fraud? Now, I'm talking fraud just as a concrete example, but machine learning use cases cut across verticals, and even within a single vertical, even within a single line of business in a vertical, the use cases are very extensive. So, again, to make a prediction and to respond to them has huge business value and quality of life value. So, for example, common use cases based on the way a customer is behaving on our website and behaving in our call center. What's the likelihood of that customer that's going to churn? Now there's a likelihood, and then there's a response to that likelihood. If it's above a certain threshold, 0.9, maybe a human being does something, calls them up, maybe a software system does something, sends out an email, or whatever. But predict, respond is basically the idea. Saving lives. What is the chance of the person in the emergency room developing sepsis in the next 4 hours? Obviously, being able to predict that and then respond to it is an immensely valuable thing to do. What is the chance of someone leaving the emergency room coming back within 30 days? If it's high, then maybe we keep them in the emergency room. Maybe we keep them in the hospital, something like that. But again, I think those two examples just sort of give you the spectrum of this predict and then respond, which is extremely valuable. And that response can either be an automated software system, an alert, send something out, or it can just be contacting a human being to use the deep knowledge of a human being to follow up on it. So let's look at this from H2O standpoint. I think it's very important, again, to divide the world up into model building and model deployment. They're connected, of course. So let's sort of keep that distinction in mind as we progress. So, H2O Open Source, we're going to dive deep into this, but what is it? It's basically a way to build accurate predictive models against massive data sets, gigabytes, terabytes of data, and relatively quickly. How does it do that? It does that because it's architected in a distributed in-memory way with optimizations about key value pair lookups and things like that, but basically distributed across multiple servers, divide and conquer, and in memory, not wasting time writing and reading from disk, makes this super fast. And it's scalable as well. If you're going to run it against terabytes of data, you're going to run it against, dozens of servers versus gigabytes, which could be less than 10. So really what this does is it leverages existing Hadoop or Spark clusters. You can build your own clusters. We now allow a Kubernetes architecture to build your own. But the bottom line is to build these predictive models against these large data sets. Now, from a model deployment standpoint, the H2O Open Source allows the data scientist, when the data scientist is happy with the final model, to export that model into a deployable format or artifact. I'm going to show you today how easy it is to deploy this artifact, and I'm going to show you today how flexible this artifact is, meaning this one artifact that has a standardized, repeatable format, basically a Java binary that can run in any JVM. There is sort of a Python version 2, but I'm going to concentrate on Java. But this one artifact can be deployed to any JVM, whether that's a REST server that takes, HTTP requests across the internet, whether that's churning through tens of thousands of records on a database and batch predicting from the records of the database, and then having a new column with the probability of this prediction. It could be in a Kafka stream, and then predicting as it pulls messages off the Kafka flow. So the point is that this artifact is easy to deploy in all kinds of different situations to achieve that business value that you're going after. So here's the worldview. If you're an enterprise stakeholder, you see this view if you're an enterprise architect, you see this view. If you see a data scientist, you probably don't see this. If you are a data scientist, you probably don't see this full view. But the point is, in large systems, at banks, insurance companies, or as I said, just any Hadoop or otherwise environment that is very carefully protected, as it should be, many people are involved here. So the data scientist, why does a data scientist like H2O Open Source? As I've been saying, they can build accurate models against massive data sets, but they also do it in a familiar way. Data scientists will be using a Jupyter notebook launched from his or her laptop that's connected to Hadoop. Data scientists will be using Python as a language and so on. Data scientists will be using the algorithms they recognize. This is all sort of the front end to the massive compute that's happening on the cluster of servers in the background. Another nice feature is that the data scientist can easily generate documentation that's standardized and extremely thorough. It's a Word document, usually 25 pages, that describe everything about the experiment, and it's just a click of the button. So that's very valuable. And then also the ability to say, I'm ready for my model to go to production. One line of code, export it, throw it over the fence to the DevOps team, let them take over it. So DevOps likes it because it's typically easy to deploy. As I said, it's sort of this standardized Java binary that's easy to incorporate into any JVM Java software. And also you can follow a software development lifecycle. So if you are familiar with the world of code and software and putting that into production and putting new versions into production and so forth, that's a very controlled step-by-step process, and you can do the same exact thing with the model that is generated by the data scientist. Business owner, of course, really it's the imagination of the business owner to sort of imagine, what kind of transformations can be done using machine learning. Of course, there are, problems that need to be overcome. Do we have enough data? And so on, but I think anyone familiar with where technology is going knows that machine learning, which is a subset of AI, is really transforming businesses, across verticals. Now, enterprise architect, is this well architected? Will this be deployed on my system in as lightweight way as possible? Does it follow proper architectural principles? And then does it follow, governance, and does it implement security, and so on? As I said, to a data scientist, that oftentimes is invisible or doesn't seem important, but to an enterprise architect who's putting all kinds of stuff, software, onto their systems, that has to be done in a very careful, protected way. So the webinar today is going to focus on the world of the enterprise architect, even though that architect will be kind of seeing the world through all of these other persona that we have here. So let's dive into the model building stage specifically. We'll return to the model deployment stage, and let's start to get technical. This is the worldview of the data scientists using H2O Open Source. In some ways, the worldview is just the left two boxes, because what happens on the compute is just the magic behind the scene. But the data scientist is using a familiar environment, as I said, Jupyter, let's say, familiar languages, Python, let's say, to build models using familiar algorithms, powerful algorithms, XGBoost, gradient boosting machine, generalized linear models. These are very powerful algorithms to reach those accurate predictive models. Also, additional capabilities here are stacked ensembles, AutoML, grid search, things like that. And then notice it is supervised and unsupervised learning. But the key here is that I want to use my Hadoop cluster or any clustered environment to leverage that distributed in-memory architecture of H2O Open Source to build my models, not on data that I've uploaded from a CSV file to my desktop, not on something that I'm pulling from a database live, but on gigabytes, terabytes of data sitting on their systems. So, many of the banks that I work with, using fraud as an example, they're using terabytes of data to run machine learning models against it. So what we're going to do now is we're going to kind of dive a little bit deeper, and we're going to start focusing a little bit more on the right-hand side of this diagram. Now, there's a lot going on here, but the intent of this slide is to show what the alternatives are to implementing or deploying the open source software on your system. So as I said, the IDE, the development environment that the data scientist uses is pretty much what they choose. The key is that they just install our libraries on that IDE. If it's Python, a simple pip install, conda install, whatever, get you those libraries. Now, a key distinction here in terms of choice or alternatives is, are you running this on Hadoop or are you not? So if you're not running it on Hadoop, you could just stand up X number of servers and run H2O3 against it, and it actually has a way of organizing itself on those servers into its own distributed coordination. You can implement your own Spark environment, or you can go against Databricks, for example. Those are all different alternatives. One difference you'll see, at least currently, is that our Hadoop, that implementing it on Hadoop allows you to use a product that we call Enterprise Steam that we'll talk about fairly much. And basically, Enterprise Steam is that governance and security layer that that makes the use of our product by multiple users very secure and governed on the Hadoop platform. I do want to make a distinction between what we call H2O3 and sparkling water. H2O3 is pretty much the core of open source. It's all the algorithms that we showed above. It's the distributed architecture, in-memory architecture that we showed above. Sparkling water is sort of a wrapper or a skin around that allows the user to integrate machine learning code from H2O with pure Spark code. So if I'm in Jupyter Notebook, I can use H2O and Spark interchangeably. And then sparkling water runs on Spark as the engine. So if it's just pure H2O3, it's running on a MapReduce compute engine. If it's sparkling water, it's running on Spark. And then anyone familiar with the Hadoop world will recognize Yarn, and Yarn is the resource manager. It divides the world up into pools of resources, and users are use part of the pool. and that sort of helps divide which users can use how much resources, because these systems typically have multiple lines of businesses or multiple users in a single line of business only. So main point here is that there are many ways to do this. I'm going to concentrate on Hadoop today. And one point, I'd like to reiterate is that it does, at least now, because we do have roadmap for Enterprise Steam, but right now it allows you to leverage the security and governance of Enterprise Steam that we'll look at in just a few minutes. So now we need to sort of jump into a very key concept. The concept is called an H2O cluster. Now, of course, a Hadoop cluster is n number of worker nodes, hundreds oftentimes. A Hadoop cluster is a subset of worker nodes that are working together to run through these compute-intensive algorithms in that distributed in-memory way. So a user defines the size of the H2O cluster. The size of the H2O cluster is pretty much defined by how many nodes do I want it to run on, how much am I dividing and conquering, and then how many gigabytes of memory do I want on each node. And then, a different user will do the same thing. So the key concept is an H2O cluster is a subset of the worker nodes that are all talking to each other to do the distributed compute. And we'll see in the next slide that if you're seeing things from a Hadoop admin standpoint, this is a Yarn application. I'll do a demo, we'll go on to the Hadoop side, we'll look at the Yarn UI, and then we'll see what this looks like from a Yarn standpoint. But this is a Yarn application with an application ID. There's a sort of a rule of thumb that we provide. How big should I make my cluster? It's typically take your data set size, multiply it times 4. There's a lot of intermediate processing and things like that. And then lean towards fewer nodes with more memory. So as an example, if I have a data set size of 200 gigs, that's going to occupy, or you should carve out, 800 gigs of memory for that data set to be processed through the machine learning algorithm. So then, 20 nodes with 40 gigs each is a good way to go. Now, what I'm about to show you later on is that users kind of can do what they want at this point. Maybe I'll launch 10 clusters and do 10 different things at the same time. Maybe I'll use, way more memory than I think I need just because maybe it'll help. So one thing that Steam is going to do is going to sort of corral those users and build guardrails around them. So before they submit to Yarn, it's sort of pre-filtered. No, you can't do that. We're not allowing you to build a cluster with 200 nodes and 50 gigs of memory on each one. So we'll see that Enterprise Steam, part of the governance is building these guardrails around users so that they use the Hadoop environment properly. And then let's just drill down right now on a single cluster and just kind of look at some of the properties about it. So one thing is that user A and the single cluster of user A is isolated from all other users and clusters. So if you and me are using the same exact data set at the same exact time, we're completely isolated. I've got my data set in memory of my H2O cluster. You've got your data set in memory of your data cluster. So there's no sharing of data among users or among clusters. Another important idea, as I said before, that this is a Yarn application with a Yarn application ID. It just sort of launches this long-running application that exists until the user terminates it, and then it all disappears. I'm going to show you one other advantage of Steam is it has settings so that there's auto-terminate. So after a certain amount of idle time, the cluster just terminates. Because you can imagine a user not being a good citizen and just saying, I'm just going to keep my cluster running all the time and not using it most of the time, it's just sitting there wasting resources. So that's yet another way that Steam provides the governance around user to make sure that these resources are being used properly on the Hadoop side. Another really important thing is that you see this H2O jar on all these worker nodes. That's not installed there. That's just pushed from the client to the Yarn application. And then when the Yarn application is terminated, they disappear. So one very important message I'm going to make about the architecture of H2O is nothing is installed on the Hadoop cluster. You'll see it's completely an edge node client that, you know, if you say, oh, there's a new version of H2O, you're not touching your Hadoop cluster. You're just touching that client. And that obviously has huge advantages to anyone doing administration on the Hadoop environment. But, you know, again, as a data scientist, you don't see these things. But imagine if the Hadoop libraries had to be installed on every worker node, you would be waiting a long time for that new version to be implemented. So that's really one good architectural feature of H2O. Nothing's installed on the Hadoop cluster. We'll look at how things are installed in a little bit. So different users are distributing their work, their high compute, to each of their H2O clusters to build models. They're doing it through the Jupyter Notebook or the RStudio or whatever they use. And now, as an enterprise principle, we want to use Steam. I've already indicated through some anecdotes previously in the webinar, you know, what Steam does. But one fundamental principle for implementing H2O open source is to use Steam. And I'm going to talk about 3 high-level reasons to do that, and then I'm going to run you through a demo just to make it a little bit more concrete. But as I said, Steam provides security and governance to H2O users and their resource consumption. And it does this upstream from when the application hits Yarn. Yarn still does what Yarn does. HDFS still does what HDFS does. Ranger or whatever, your security policies, which HDFS files can be accessed, which Yarn queue you're allowed in. You know, that native world of Hadoop is still operating, but Steam corrals or governs things before it hits that world. So as an example, you know, you can create what we call a profile and assign it to individuals where you can only have, you know, X number of concurrent H2O clusters running. In this case, the user can only have one H2O cluster running. It can have no more than 10 nodes, and it can have no more than 10 gigabytes per node, and it'll auto-terminate after 3 hours of idle time. Let's call that a light user. Let's say that there are a, you know, small number of elite power users. Well, then you can define a profile for power users that say they can have 5 clusters running at the same time. They can go up to 200 nodes. They can go up to 50 gigs per node, and I'm not going to auto-terminate it. But that's the governance that's automated and assigned through Steam, as we'll see in a little bit. So that's one important feature of Steam of why it's a pretty critical best practice for H2O. The other one is that you know, there's a lot of security that goes with running H2O on Hadoop that doesn't really have to do with, you know, individual users and their resource consumption, but just fundamental security implementation. So the admin has the ability to configure Steam and deal with all of those security concerns. One thing it does is it allows authentication against the same LDAP that Hadoop uses, and the user authenticates into Steam. You know, on Steam, you can manage all the certificates for making secure connections and stuff like that. You can configure the Kerberos authentication through Steam. I'll explain that in a little bit. You can, you know, in one click of a setting, you can turn encryption in transit on, so that when H2O nodes are talking to each other, it's encrypted going across the wire. You can do all that from the UI of admin, part of the Steam software. Now, one key feature here is that Steam implements user impersonation. What that means is that Hadoop is going to authenticate Steam on the system when it tries to launch a Yarn application. It'll do that typically, through Kerberos. So basically, it's always saying, okay, I know you're Steam. Are you allowed to do this? Well, if that were the only way that the the authentication flowed, then anything that happened on Hadoop would just be owned by something called Steam. So me, Greg, using it, I would have no idea whether this cluster was owned by Greg or Mary or Steam or whatever. So user impersonation means that even though Hadoop challenges Steam to authenticate itself, the user name flows through, so that all of the security mechanisms on Hadoop are against the user. So if I'm trying to access an HDFS file system that I'm not allowed to access when I import data from my model building, it'll say you don't have permission to do that. If I'm looking through the audit of who ran Hive queries or whatever, because we can connect to Hive from the H2O cluster, it'll say, Greg, Mary, etc. So user impersonation means that even though Steam as a service, as an automated service using the system is authenticated, the user is flowing through and recognized and challenged at the next level. So the third thing about Steam is similar to the other one. It's just, again, the ability to configure not necessarily security, but integration and environments. So if I want to use a new version of H2O3 or sparkling water, I just upload it to Steam, and it's available to all users I give permission to. If I want to configure, various properties on generating auto documentation, I can do that through Steam. If I want to configure the connectivity to Hive, I can do that through Steam. If I want to configure who uses which yarn queue, I can do that through Steam. So again, this sort of central console to not just implement security, but just implement integration as well. So one more slide before we have a demo, and then we'll be jumping to the next topic. And I see we have about 10 minutes until we have questions. So I'll move a little bit quickly here. And basically, Steam is installed on an edge node, which means that all the Hadoop libraries are there and managed by Hadoop. So if there's any updates in the configurations for the cluster, they're also updated here. And then basically it's just a very lightweight install that installs a small web server, a MySQL embedded database, and then it uploads versions of H2O and sparkling water. As far as high availability, it currently runs on an active-passive model where you have a hot and cold version of Steam. One of them's just shut off sitting somewhere. They're sharing storage. And then if one goes down, you bring up the other, and then everything comes back to life. And because it uses MySQL embedded DB, which basically runs from a file system, you're all ready to go. And on the right-hand side, I said nothing's installed on the cluster. There is one configuration, and that's to configure the configuration file core site XML to make the Hadoop proxy user or impersonation occur. Anyone who's done this, it's identical to the way you would use Hive user impersonation or any other kind. It's the same exact thing. So there is one-time configuration on the cluster. After that, any updates to Steam, any updates to H2O, any updates to sparkling water, they get done only on the edge node side. and no changes on the Hadoop side. So because we may run out of time, I want to finish the slides and then come back to the demo of Steam and H2O3. But I do want to touch at this point the model deployment side of things. Basically, if you don't get your model into production, it's sort of a hobby, right? Because you're not really doing anything for the business, is why we pretty much, are here to execute the business. So until you get into the production, you really haven't achieved the value of machine learning. Some may argue from some esoteric points, but I think fundamentally that's the story. So basically, the data scientist can run a single line of code that exports an artifact called a mojo, which is a Java binary, and I'll get into a little bit more detail, and that you can either integrate into your own software system or you can integrate it into software that we provide. We provide software to run a REST server. We provide software to deploy the mojo into a database and do scoring against, batch against rows and rows of data. We provide software to run, Kafka and MQ queues. We have integration into Snowflake that's really nifty, and it's very simple to do your predictions from SQL queries against Snowflake. And then, we also have some other advantages for doing it on our software, and I mentioned the model ops and so on. But the point is, a lot of enterprises do it on their infrastructure, their software, their way, but this is very flexible to do that. I'm focusing on Java. There is a Python version of this. The Python version is slower because it's not a compiled language. And the mojo, the Java mojo, typically scores in less than a millisecond. So data going in to the mathematical logic, data coming out, that typically takes less than a millisecond, so you can get very high throughput on these scorings. Now, just to sort of take a look at deploying it to your own infrastructure, you can see those logos on the right. They're not finite. It's just to give you the idea of how flexible this can be deployed. We have a customer who has deployed it to a REST server and uses Excel spreadsheet, a VB script, to call that, and as they drag down cells on the spreadsheet, it forecasts into a new column next to those cells. So, super flexible in how you can get these predictions into a software or user context where it's useful. So, cloud, on-prem, edge, device, same mojo, works everywhere. Even though it's Java-based, you can run it in C++ or Python if you have that need. Batch, real-time, streaming, a little bit different than real-time, but most people think of that as similar. Super wide list of target environments, as I've shown on the right, very fast scoring. And then again, from a data scientist standpoint, this is the result of those really complex, well-known algorithms that they've been using to build the model. Now it's reaching fruition in a production environment where real data is coming in, real predictions are coming out, and real responses are happening either by humans or by automation. Okay, so I'm going to now back up and do the demo, which means I have to jump this guy in front, and I'm hoping everyone can see everything. Maybe I can get a chat from my co-presenter if you're not seeing the Steam.
Yeah, Greg, we can see it just fine.
Fantastic. So I'm in here as a user, and what I've done is I've launched a cluster by clicking a button. I'm not going to launch a new one, but I'll show you how to do it. New cluster. I'm going to choose here. There's multiple versions of H2O. I'm going to choose the latest one. Size of my data set, I'm going to say it's 20 gigs. This Steam does the heuristics of building the size of your cluster using those rules of thumb. I'm just going to go in the default queue. I could put another one. I could have had this assigned to me when I logged in. It pre-populates. And then I can override things, but you're going to see that what I've put in, I would have built a cluster with 4 nodes and 32 gigs of memory, et cetera, et cetera. So what I'm going to do now you see that I have launched the environment from here, and I can terminate it from here, or it'll auto-terminate because that's what the admin assigned to me. But now I'm going to go up to Jupyter, and I'm going to, just give a quick, simple demonstration of running this software. So right here, an important security point is I've got my username. I don't have a user password. I have a token. Of course, that's clear text, so if you pass that to someone else, they could use it. But the important thing is this token can be stopped by the admin. So if there's any abuse by a user, you can basically prevent, you can retire that token, and therefore the user can't use the system. So it's like a password, but better because it can be revoked. So now I'm going to connect to the cluster. You can see I'm connected to the cluster. Now I had only one cluster running here. I could maybe have 3 or 4 if so be, if I were allowed to have that. But now I'm going to connect to that particular one cluster. Here's a summary. This cluster you'll see has 3 nodes with a certain amount of memory I can't really see right now. Yeah, with a total of 91 gigs of memory, so split between the 3 nodes. So that's what my cluster looks like. I'm going to run. I'm going to import some data. It could be HDFS. Just for simplicity, I went to the outside world here. Describe the data. I'm going to do a little bit of pre-data work to split it into a training and testing set, and now I'm running this algorithm, and you'll see it building the progress. And again, I could be running this against terabytes of data because it will be scaled out properly to handle the compute of doing so. I've run these complex algorithms. I now get super detailed metrics on the performance of it, and as a data scientist, I say, do I want to take this to production or not? And then I can download the Mojo, and then I can give it to the, I can implement it into the software development lifecycle and have it progress into a software deployment into production as software should be. So that's from the user side. I have just a few minutes, so I can quickly show you things from the admin side. So I'll log out here. So the admin sees the configurations. Going over our VPN, so it's a little slow. It's HTTPS. So, one thing the user can do is can look at all of the H2O clusters running, all of the sparkling water clusters running or stopped or whatever. But importantly, what I've been emphasizing is, it's the wrong user. Got to look that up here. 1 second. Let me take a wild guess. Okay, so now I'm the admin. That was a good demonstration of how normal users don't get the admin view. But now we'll get the admin view. And so everything I showed you before was just that user's clusters, but now I can look, now you see a giant list, right? These are all the users. These are all the users. And then the configuration, this is what I've been saying about configuring from a integration and security standpoint, security, et cetera, Hadoop, where is the Kerberos key tab that's been given to me for the service user, and so on. Similarly for Hive access as a service user. But a very important point that I've been mentioning is putting these guardrails around users, and this is what's called a profile. So a profile defines which yarn queue, the profile is set and then assigned to users, which yarn queue, et cetera, and here is that important guardrail system that I told you about, that if you're assigned this profile, you only get this number of nodes, you only get this amount of memory per node, you only get this amount of clusters running at the same time, and you're only allowed to choose 24 hours as idle time before it shuts off. And in this case, you're only allowed to use it 24 hours at a time. So, you know, you would have to create a new cluster that can be increased or whatever. So, main point here is I'm showing you from a Steam standpoint those 3 points I mentioned: building corrals against the users so that they don't hog the resources and abuse the system, the Hadoop system, and then all the configuration that ascertains the correct security and integration is occurring. And finally, I'll show you from a yarn standpoint. You'll see my name because I'm running this cluster called demo. And as I said, H2O runs on MapReduce. So you can see that Greg K is running this cluster. It has 4 containers and so forth. And until this shuts off, this sits there as an open application with these static resources until either Steam or I turn this off. In the meantime, I can upload data, I can run machine learning, I can rerun machine learning, I can just try new things, and it'll always be using this application ID and the resources assigned, which from the H2O side is called a H2O cluster. So having said that, I'm almost on time, and I'm now going to ask if there are any questions. So if you have any questions, please. Well, actually, let me summarize. H2O runs model building against massive data sets. We talked about how it can do that. Nothing's installed on the Hadoop cluster. Use Steam. Mojo makes deploying easy. If you don't deploy your models to production, you really haven't achieved the business value of machine learning. So now I turn it over to questions for anyone who wants to post them, which I can now see on the console from BrightTalk. So please write your questions if you have them. I see them now. Can H2O3 and H2O3 with Spark run on AWS? Yes. We have customers who have integrated it with EMR, and it's identical to everything I've shown today. So the answer is yes. AWS EMR integration as the Hadoop cluster is not only doable but commonly done. Can we use this for R language? Yes, you can use R, you can use RStudio and so forth. I've used Python just to keep concretely with what I'm more familiar with, but yes, it's commonly used for R as well. How many users can Steam handle? That's a good question. I don't think we've come close to the limits, but I can say that some customers will assign Steam to different lines of businesses. So one admin has the Steam worldview of that line of business and doesn't get to see what the other line of business is doing. So that's one way to handle large users, even though I don't know if we've hit limits on that. How seamless is to integrate the H2O Steam to an existing Microsoft Azure network cloud so we can have our models deployed in H2O Steam, from H2O Steam, that can talk to the Azure data lakes and also get authenticated using Azure AD? So this is similar to the previous question of running it against EMR. Now, you know, if you had the Hadoop Azure version running, you could do that. So you know, the question is kind of, I'm not sure exactly what it's asking. Honestly, there's a lot going on. So I would say, sure, you can run this this deployment architecture against Microsoft Azure and use their AD, and you know, I know they have like AD on-prem, AD in the cloud, stuff like that. How many users can Steam handle? I mentioned that before. It really, we haven't really hit any limits on it, but sometimes you logically want to assign different Steam instances to different lines of businesses just to keep things tidy from a line of business standpoint. Can you expand a bit more on the advantages of using an edge node client like H2O? One of the big advantages I've said is that it basically confines all configuration, software installs, and everything to the edge node. An edge node is updated because it's managed by the Hadoop cluster. So that's one of the main reasons. But one thing to keep in mind is when I ran my Jupyter Notebook, I ran that from my laptop. It just used Steam for all the security, basically. It basically authenticated Steam. So even though Steam is on the edge node, you can run your client on your local environment because it uses the Steam API to authenticate. Where is the best place to start with building models with H2O? We have tons of tutorials. We have tons of blogs. We have tons of resources. So I would say get to our site and just go to H2O tutorials. And even though we've been talking about enterprise and hundreds of servers, you could run this on your laptop as well. So that would be my suggestion there. How seamless? I think we are marked as, I think we already answered that, or I answered that as best I could regarding the integration of Steam with Azure. I see that as similar to the AWS EMR question. Oh, I see, I'm working downwards. Is Mojo runtime completely open source? It's compiled, and the API around it is open source. So you're not going to see code in the Mojo, but you will, you know, the ability to load it into your system, the ability to make predictions from it, the ability to wrap other functionality around the simple act of, here's some data, give me a prediction. Maybe you want to learn more about that prediction. Our API around that to write a wrapper around it is open source, but the Mojo is compiled. So I believe that we are at the end of the questions, unless unless anyone has more questions to put into the queue here.
Yeah, Greg, I think this is probably a good place to stop. If we do have any other questions, feel free to drop them in, and we can follow up via email as well. But I would like to thank Greg for taking the time today and doing a great presentation. I'd like to thank everyone who joined us as well. The presentation slides and recording will be made available on our Bright Talk channel in a few hours, and we hope you have a great rest of your day.